Hello everyone. So let's solve this LeetCode medium problem, maximum frequency of an element after performing operations 1. So before moving on to the problem, I would like to say the concept which is used to solve this problem is very important. If you are not already aware about how to use prefix difference arrays concept, then I'll be explaining you that. And this means concept is really important. It is that much important that it was asked to me in Google's technical interview round for SWE2. So this is asked a lot, and it is used in a wide means a very wide range of problems. So it can be used anywhere. Hence, it is very important. So let's move to our problem statement. So we are given an integer nums and two integers k and num operations. Now we can perform an operation num operation number of times on this given array nums. And now in each operation what we can do is we can select an index I that was not selected in any previous operations. That means we can only select a particular index at most once. And now we can add an integer in the range minus k to k. So we can add any integer in this range minus k to k to nums of I. Now we need to return the maximum possible frequency of any element in nums after performing the operations. Okay, so let's see the given input. So suppose we are given the nums as this. Now we can perform two operations, means two times we can add the range integers in the range -1 to 1 to any of the two indices. Okay, and then we have to return the maximum possible frequency of any element. So what can we do here? So let's try to make all the elements. What can be the minimum element that we can make? So we know the minimum element that we have here is equals to 1 and the maxi is equals to 5. Hence the minimum element that we can make is add -1 to this element 1. So we can make 0, and the maximum element that we can make is add 1 to this maximum element. So that means 0 to 6. So let's see what are the possible frequencies of these elements which we can make after applying two operations. So for 0, we can make this 1 as 0, so it is possible, but we cannot make this 4 as 0 or this 5 as 0, because 4 can at most be converted to 3 only, and this 5 can at most be converted to 4 only. So for 0 the maximum frequency will be 1 only. Let's try for 1. So for 1 this is already 1, so it is good. For 4 we cannot make it 1, and 5 also we cannot make it 1. So hence for this also it is 1. Now let's try to find the frequency of 2. So we can make this 1 as 2, okay, using one operation, and we cannot make this 4 as 2. Okay, so this is also not true. So again the maximum frequency of 2 also will be 1 only. Let's try to make all elements as 3. So means we cannot make 1 as 3, we can make 4 as 3, but we cannot make 5 as 3 as well. So hence the maximum frequency here also will be 1. Let's try to make all elements as 4. So 1 cannot be made as 4. 4 is already 4, so it is good. Now we can make this 5 as 4 by adding -1. So we can make this 4. So hence the maximum frequency of 4 will be 2. And if we try for 5, then the maximum frequency will be, we can make this 4 as 5 by adding +1. So it will become 5, and this 5 is already there. So for this 5, the maximum frequency will be 2. And for 6, again we cannot make 1 and 4 as 6. Only this 5 can be made as 6. So hence its maximum frequency will be 1. So we see the maximum frequency that we can make for any element in nums after performing the operation is for 4 and 5, whose frequencies are 2. So since 2 is the maximum frequency possible, hence the output here is 2. Okay, let's see for another input. So we have these elements 5, 11, 20, 20, and k equals to 5. And we can only perform a single operation. So we know 20 is occurring 2 times, so it is good. So we'll not try to change that. Now we'll see whether we can make 11 or 5 as 20. So we know the maximum that we can increase 11 is by 5, which can make it 16. So hence we will not be able to make it 20. So hence for 20 the maximum occurrences is 2, so it is good. And also we can say this 5 and 11 we can make numbers such as numbers which lie between, suppose 6. We can increase this 5 to 6 and decrease 5 from this 11 to make it 6. So 6, 6. So this 6 frequency will also be 2. We can also similarly see we can make 7 as well, 8 as well, 9 as well, and 10 as well. Okay, so these elements will also have a frequency of 2, means, but we know we will not be able to do that because we are only allowed a single operation, and to make these values we need 2 operations. So these are not possible here. So hence the only element which will have been which will be having 2 frequency, which is 20 here, and hence the output here is 2, which is the maximum frequency possible. So like what can be the like most brute force way of solving it? So we have like utilized the brute force approach here only. We saw, means we find out the minimum element in nums, we find out the maximum element, and then we see like what possible ranges of elements we can make. So we see like we can make what elements we can make: mini minus k till maxi plus k. These are the ranges of elements that we can make, right? Now to identify like how many times these a particular element can be made, so if for a particular element x, we need to know like how many times we can means make this x. So we will iterate through I for 0 to, means we'll iterate through all the elements of nums and see like whether that a particular element can be converted to x or not. So there will be two cases, like this x means it will be like occurring in nums only, okay, it already exists. So if it already exists, then we will simply not apply any operation, right? So this will be the count exact. That means count exact means like x is present count exact number of times in nums. And now we need to like find out this count make. Okay, so this is the count which will means these many number of elements. Suppose it was y, so I can convert it into x by utilizing one operation. Okay, so hence, and when can we convert this y to x? When it is sure that this means this x should be lying between y minus k to y plus k. Okay, that means we can convert this y to x. It means like the absolute difference between y and x should be like less than or equals to k, right? This is what we mean by it simply, right? So it should be less than or equals to k. So if this condition is satisfied, that means we can convert this y to x, and that means we will be increasing this count make for this particular x, and this count exact is initially counted. Now once we find out this count make, we know like we cannot convert all the elements because we are only allowed num operation number of times. Okay, we can apply operation num operation number of times. So hence how many times we will be able to apply it? So we know like count exact is one way, so we'll definitely be having the count as count exact. And now we can apply this operation plus minimum of what? Minimum of num operations comma count make. And also like this may be the case that count make is in it. So this will be covering all the cases where the exact occurrence of the element is also counted, as well as we are number of times we are able to make it. Okay, so this is the like the overall means solution at each step, and we'll be calculating it for each x from mini minus k to mini plus maxi plus k. Now let's see the constraints. So we see like nums of I can go up to 1e5. So the range that we'll have is like 1e5 into 3, because plus 1e5 on the right and minus 1e5 on the right. So 3 into 1e5 will be the range of elements that we'll check, and we'll be iterating through this array once. So again 1e5. So overall complexity would be 3 into like 1e5 into 1e5. So 3 into 1e10. Okay, so since as we know like this will obviously give TLE, and hence we need to think of something means optimized here. So let's see this brute force code first to like get the intuition clear. So we find out the range of mini and maxis, then the start will be from mini minus k to max plus k. Okay, now we initialize this max frequency variable, which will be updating after we calculate for each target. Now count in range means we those values which can become target, means we can, this is the count make, and count exact, which means this nums of I, this target is already existing in nums. Okay, now for each x we see like whether this condition is satisfied. If it does, then we'll increasing our count in range, and if it is already equals to x, then we'll increasing our count exact. Okay, now you might see that this formula will not work here. Okay, this formula may give extra means less result, because in count make we are already means will also include those elements which are count exact as well, because obviously we can make those elements which are count already as exact to will be increasing the count make as well, since we need to modify this formula to some extent. Okay, so we know like count exact plus num operation is the maximum number of like this is the maximum that we can make the occurrence of any element x. Okay, and the maximum that we'll be able to make is what? It will be count make. Okay, so this will be like the formula, final formula. This count make will be including both the counts that we can convert as well as the exact counts, and this is like the count exact plus number of operations. So we'll be taking minimum of these values. Okay, so this is the correct formula for this. I because once we saw the code, we saw like this count make is including these values as well. So hence we need to modify that formula. So let's see the code. So the operations needed is, since means we needed to only make these values, we can convert these values, but we are only allowed to like we'll be considering only those values which are not already exact. Okay, so since count and range already includes those values, so either we can like directly use that particular formula or see the logic here as well. So can convert will be simply minimum number of operations plus this operations needed. Okay, comma operation, and then it will be simply count exact plus can convert. And this stuff will be updating our maximum frequency with maximum of max frequency comma total frequency, and it will be returning. So obviously we see like this will be of the order of 3 into 1e10, which will give us TLE here, and hence we need to optimize this approach. Now comes the most important approach of prefix difference arrays. Okay, how do we use prefix difference arrays in these kind of problems? So let's first know like what is a prefix difference array. Okay, if you are like already aware of about it, you can skip 1 or 2 minutes. But a prefix difference array is, suppose we have an integer array given, right? Integer array we are given from 0 till n minus 1. Now someone says you to like from L to R, you are required to increase all the elements in the range by this value. Okay, so either one way of doing it would be to iterate, means what you are asked is you are given this L to R multiple times. Suppose one time this is the L to R, then this is the L to R, then this is the L to R. Okay, and then they finally ask you the final nums array, the modified nums array. Okay, so one way of doing it would be to simply like for each L to R, you go from L to R and update, means increase the value of each L. Okay, so one way of doing that would be that, but obviously that would not be feasible because you are taking big of n for each query. Okay, so how do we like do this efficiently using prefix difference array? So we make a prefix difference array, prefix diff, which denotes that if this is the range from 0 till n minus 1 and you are required to increase the values from L to R, then what we'll do is at L we'll be increasing it by plus 1, and at R plus 1 we'll be decreasing it by minus 1. Okay, so the value that by which we have increased at index L will be decreasing it by the same amount at index R plus 1. Okay, why this works is basically because here the difference part that we have done already. Now comes the prefix part. So once we have processed all the queries, this plus 1 here denotes that this plus 1 will be progressed to all the indices from L, because L to R we need to increase. That means from L, then L plus 1, L plus 2 till R we need to increase all the values. Okay, so hence this plus 1 here denotes that when we take the prefix sum, what is prefix sum of A? It is simply prefix of I minus 1 plus error of I, right? So if this value has a plus 1 here, then that means this plus 1 will be progressed in the next step as well, because of the prefix value being prefix of I minus 1 plus error I. Then this plus 1 will be ignored, means moved forward, and as soon as we reach R plus 1, we want that we do not need to progress this plus 1 forward. Okay, because we only need to increase the values from L to R. Hence we'll do minus 1 at the index R plus 1, so that this plus 1 and minus 1 gets cancelled with each other and the original array still remains the same only. Okay, so this is the core logic. This is the core logic of prefix difference arrays. Whenever we want to increase the elements in the range of L to R, what we do is we increase at index L and we decrease at index R plus 1. So I hope this is clear. Now let's see how we'll be using it in our like given problem. So in our given problem, we are given that we can make any element x, this can be converted to what elements, what range of elements? X minus k to x plus k. And now our task was to find max frequency of any element. Okay, this was the task. So what can I do here? So what can I do here is, we know like if we have the given array nums from 0 till n minus 1, I can like simply find the range of elements that we can make for each element. Okay, so it will be from like num0 minus k to num0 plus k. Okay, and so on till nums of I minus k comma nums of I plus k. Okay, so each element will have a range from L to R, right? So how do we like find out what elements? This means like nums from for nums of 0 for nums of I, this means like we can create any element in the range nums of I minus k to nums of I plus k. That means all elements which lie in this range will have its frequency increased by 1, right? That is what we need. So this is the same problem that we need to do. Here we are given that from L to R we need to like add some values to all elements. Okay, so here also we need the same. For all elements in this range we want their frequency to be increased by 1. So hence we will be using again the prefix difference array that we discussed. So what we'll do, we'll create a new array where this nums of I minus k will be increasing the value at this step by 1, and till nums of I plus k we want to increase. So at nums of I plus k plus 1 we will be decreasing it by 1. Okay, so this means that now once we have like done these values, in the end after we have done this for all the ranges, means all the intervals for each element, then in the end when we take the prefix we'll be able to know like if this was the range, this is the number line. Okay, let this was a number line and this was 0, 1, 2, 3, minus 1, minus 2. Now suppose here it was plus 1 and here it was minus 1, and here again it was plus 1 and here it was minus 1. So now when we take the prefix sum, at this step will be get initially it is 0, here also it will remain, means all other places is it 0. So here 0, then we got plus 1, so 1, then again we got plus 1, so 2, then we got minus 1, so it becomes 1. This is the prefix array. Then it remains 0, so 1 remains 1, then we again got minus 1, so it will become 0. So from this we saw that since this plus 1 was added at 0 two times, means first it was added from minus 1 to 2, because minus 1 is at this, and then it was added to 0 to 0 only. So that means it was added as this 0 for two times. So that's why the frequency of 0 here is 2. That's why the frequency of minus 1 here is at 1, because it was added once here only. Here also it was added once only. So that's why the frequency of 1 here is 1. Similarly, frequency of 2 here is also 1. So when we have already processed this for each element, so the ranges, and we have done the prefix difference, then when we will like accumulate the prefix sum at particular step, we'll be able to know the current frequency that we have for that particular element. Okay, so this is like the approach that we'll be using. And now you might consider the case like how we'll be handling those cases where the exact count. Okay, to handle those cases what you can do here is like we know like we'll be using the same formula. We can create a separate map for that. So create a separate map to count the occurrences of each element in nums. Okay, and then like iterate through these values, and we know like since either we can create a number line to store these values, so like either we can create an array of size what, since these can go negative as well, so we will need to increase the indices, so approximately 3 5, because we know the range was 3 5. Or we know like each array means each point in nums has only two endpoints. Okay, L to R. So we can simply, we are only means required of this L as well as R, the element present at these ranges. So we can simply use a map as well. Okay, map of int comma int. Okay, which means that MP of L will be increasing it, and MP of means instead of L we will need R plus 1, because we will be decreasing MP of R plus 1. Okay, now once we have done that, then we'll be able to like traverse from the start, and at particular step we'll be able to know the current occurrence of the current accumulation that we have done till a particular element. Okay, in that form. And you know it wonder like what if this L to R that we have, suppose the element was 2 and k was 3, so the new range will get minus 1 to 5. So this 2 will be skipped, right? So for these means this 2 to get included in our map, to find the exact count exact value, what you can do here means we know like MP of L will be increasing, MP of R plus 1 will be decreasing, and if like this does not exist, so we can simply like mark MP of 2 as 0. Okay, so we'll mark MP of 2 as 0 so that this becomes a part of map. Okay, so that this is not skipped while we are like traversing through the start to account like making means all elements as this particular value to maximize the frequency. So I hope this is clear. So this will be the like the same approach that we'll be using. We'll be creating the map to store these prefix difference. So instead of like a vector, we saw like since we only need the endpoint, so we can use a map as well here. And like the entire logic still remains the same only. So let's see the implementation of this. Then like things will get clearer. So we'll be creating this map events. Events will be like for the prefix difference array, and counts will be denoting the exact count of each element. Now we'll be increasing the exact count. Now this is the L point and this is the R plus 1 point. So L point was x minus k and R plus 1. So R here is x plus k. So x plus k plus 1. We'll be decreasing it. And we'll be like so that this x does not get skipped. So we'll be like if it does not exist in map, then we'll simply like make events of x as 0. Okay. Now we find the need to find the maximum overlap and need to traverse from left to right. So why did we not used like a unordered map here? Because we know like these values that we'll be processing, we need to process in from left to right, so that the sums that we have done here plus 1 gets accumulated as we move forward. Okay, on the basis of values only, because we need to deal with ranges in increasing order. So hence that's why we have used a means ordered map here. Okay, so we'll be starting from the events beginning till the end. Now the current coordinate that we have is it dot first, and the overlap will be increasing by what value, whether means whether it is -1 here or it has been accumulated multiple times +1 +1. So we'll be increasing it by that particular count. Now we'll see like whether this count means this coordinate that we have existed in the map or not. If it already existed in the map, then that means will not be means will be accounting only those accumulations which we converted, which will be converting other values. Okay, because since it already existed in the map, so number of times it already exists, we do not need to change that. We'll only be converting other elements to this particular x, right? But if there was some element which is not a part of nums, that means it was only means created by converting other elements to that particular element. Okay, it did not already exist. So that's why that's the two cases that we have. So we'll find the existing count that we have, which is stored in this counts map that we created to find out each occurrence of each element in nums. Now we can extend the existing pile using operations. So we'll be using the same formula, the current existing that we have plus number of operations and the current overlap that we have. So these means current overlap denotes the complete count like existing as well as the conversions that we can get, and this is like existing plus number of operations. So we'll be taking the minimum to find out the total possible and update the maximum frequency. And this is the case where this means coordinate does not exist in the map. So that means the complete like current overlap is the exact count. So will be means this existing will be simply 0 only. Okay, so in this case it will be num operations plus comma current overlap, and we'll be updating the max frequency and simply returning. So as we can see, like the complexity of this approach will be, since the size of map will become big of 3n at max. Okay, and at each step like finding and learning, it will be taking a log of 3n. So hence the maximum complexity will be like 3 5 into log of 3 5 and log n. So this will be approximately of the order of suppose 5v7 5v6, which is like acceptable here. So this was the overall approach for this problem, and a very important concept was discussed related to prefix difference array. So I hope like you were able to grasp the concepts discussed, and it is very important as I already discussed that it was asked in Google interviews as well. So like it is asked a lot, as well as it appears in OA also a lot of times. So if you were able to gather the concepts, make sure to like as well as subscribe. And if you have yet any doubts remaining, feel free to comment down. I will be happy to help. Let's try to submit both codes as well before we wrap up. So this is the brute force code that we did. Let's try to submit it and see in what test case this gives TLE. I hope it gives TLE. The test cases, yeah, the test cases are strong, so this will be giving clearly. And let's now submit the optimal approach that we discussed, and this should be running in, like, since we have used map instead of map, if you have used vector, maybe lead code will take less space, but yeah, this is obviously fine as well. So it does not beat most of the solutions, but this was the entire crux of prefix defense study. This, like, does not matter because it runs in approximately 1 second, which is like very fine. So I hope you were able to, like, grasp all the concepts, and yeah, thank you so much for watching.